Hello and welcome back. So we've been measuring different properties of planets in our galaxy, and so far this is what we learned. So I rewrote some of the stuff. We now know the period of the planet. How long does it take the planet to go around its star? We know the distance that the planet is from its star, and now we know the mass of that planet. So the next thing that we're going to do is measure the radius of that planet. And we're going to go back to that previous technique that we learned here. So whenever a planet goes in front of its star, it's going to make the brightness of that star go down. Now the amount that it's going to go down is going to be related to the size of the planet. So the bigger that the planet is, the more light it's going to be able to block out. So for example, if a planet blocks out 25% of the light of a star, then that must mean that the surface area of that planet must be 25% the size of the star. And so all we need to do is to measure the brightness of it and then measure the brightness of it when it's being eclipsed, and then based on that we can figure out what was the brightness of that star. Well, I'm making it out to be a lot easier than what it is, because let's go back and talk about Jupiter, for example. Jupiter was 1/10 the size of the sun, which means it's 1/100th the area of the sun, which means that the dip in the brightness of the sun is going to be about 1%. So that means what it's going to look like is not going to be like that, but it's going to be just a tiny, tiny little change in the brightness of that star. But we can measure it. It can be done, but now we can measure the radius of this planet. So once we got the radius, now we can figure out the density of this planet. So density, we learned in a previous episode, is equal to the mass of an object divided by the volume of an object. So we know the radius of this planet, so the volume of a sphere is going to be 4/3 pi r cubed. And if we know the radius of the planet, now we know the volume of the planet. And so we can take the mass of the planet divided by the volume of the planet, and now we know the density of the planet. Well, who cares? Well, if we know the density, and the density is very, very high, then that means it's what kind of a planet? It would be made of rock. On the other hand, if the density is very low, then we know that this planet is going to be a gas giant. So we can actually figure out what kind of a planet it is based on its density. So now let's take another break, and when we come back, we're going to actually be able to determine the composition of this planet.